So we have long bones. In the classification of bones, we have long bones, short bones, flat bones, irregular bones. Okay, so these are the four classifications we need to understood which are present in our body. Okay, first we will talk about long bones. What are the long bones? Where they are situated? Okay, so basically the long bones are situated in the arms. If you see your arms and legs and hands and feet, but not wrist. Okay, these are the short bones. But hands from this to this. Okay, you have, this is the forearm, arm. This is arm. This is forearm. Okay, this is thigh. This is leg. Okay, you have long bones. Okay, so you have to need to look upon your body to understood. Okay, long bones are in your limbs, upper limbs and lower limbs. Upper limbs mean upper hands, lower limbs means lower legs. Okay, so but if you see the long bones, this is your long bone. Okay, here you have the long bone. This is your long bone. So basically this long bone have different names. You have to understood that first. Okay, first you have, this is the part called epiphysis. The upper part is known as epiphysis. This is also epiphysis. Okay, this is epiphysis. Here the spelling is given epiphysis. This is epiphysis. Okay, in that you have spongy bone here and compact bone here. Okay, and you have here between epiphysis, this is called diaphysis. What is called? Diaphysis. What do you call? Diaphysis. So this is epiphysis. Okay, this is epiphysis. Okay, and this is called diaphysis. Okay, so you have to understood that. So epiphysis and diaphysis. A long bone have diaphysis and epiphysis. Epiphysis both ends, and in between we have diaphysis. The diaphysis is made up of compact bone. So we studied that compact bone is very hard. This is the very hard. So diaphysis is made up of compact bone. So in the middle we have strong bone. Okay, and he have hollowness means is to keep something. There is a space is kept. Okay, so thus it is lived as hollow. Okay, hollow, forming a canal within the shaft. This marrow canal contains yellow bone marrow, which is mostly adipose tissue. So basically, in that area, we have space. The space is called marrow canal. Okay, in that we have yellow bone marrow. You can see here in this picture here, yellow bone marrow is given. Okay, so this is made up of adipose tissue, means fat. Okay, so basically bone have two ends. Which bone? Long bone. One end is called epiphysis. Okay, and middle end is called diaphysis. So diaphysis is made up of compact bone, so that's the reason it is very strong, and it have hollow canal or marrow canal. In that, yellow bone marrow is situated. So yellow bone marrow is made up of adipose tissue. Okay, adipose tissue. Next, we will talk about epiphysis. Epiphysis is made up of spongy bone covered within the layer of compact bone. So basically, it is have mostly compact bone. Okay, spongy bones mostly have spongy bones. In your covering, you have compact bone. Okay, this is the spongy bone. This is the compact bone. So mostly here covered with spongy bone. Okay, in which area? Epiphysis. Epiphysis. Okay, Epiphyses have compact bone and spongy bone, but spongy bone is more than compact bone. Although red bone marrow is present in the epiphyses of children's bones, please remind that very important that in the children, where is the red bone marrow? The red bone marrow is here in the epiphysis. In epiphysis is largely replaced by yellow bone marrow in adult bone. So how after growing after 10 to more than 8 to 10 or 10 after 10 to 12 years, the this area is converted with yellow bone marrow. Okay, so we talked about long bone. In the long bone we have three names. Epiphysis have two ends. Epiphysis are two ends. Middle is diaphysis. Diaphysis is made up of compact bone, and he have it have halo shape or marrow. Okay, so there's a reason yellow bone marrow is situated that in that area. Next we have epiphysis area in that. Okay, epiphysis area have made up of compact bone, but mostly spongy bone is there, and it have red bone marrow in children's after growing age, that the red bone marrow is converted into yellow bone marrow. Okay, when the children become adult. Okay, in the children, long bones have red bone marrow, but in adults, in the flat bones or irregular bone have bone marrow. Okay, we will talk about later here. Okay, you have to remember that. Short bone, where the short bone? Short bones are wrist and ankles. So we have the limbs. In the limbs, upper limb and lower limbs, upper hands and lower hands. In the upper hands, it have long bones as well as short bones. Where are the short bones are located? In the wrist. This is the wrist. Okay, this is the wrist, this is the hand. So both wrist and hands have short bones, mostly in wrist region. In the ankles here, you have the leg and the foot. In between leg and the foot, you have the ankle bone. Okay, where you have short bones. Where are the flat bones? Flat bones, you see your ribs, your shoulder. Okay, your shoulder, hip bone, cranial bones. Okay, your brain is covered with cranial bones. Later you will study about that. Okay, next we have irregular bones, where you have irregular bone in our face and vertebral column. Vertebral vertebral column have irregular bones. Okay, so these things you have to remember, that where in which area you have regular bones, you have long bones, you have short bones. Okay, okay. Short, flat, and irregular bones are made up of spongy bone covered with a thin layer of compact bone. So basically, whatever the bone other than long bone, you have short bone, flat bone, irregular bone. They are made up of spongy bones. Means this type of tissue are present in spongy bone. This type of, you can see here. This is the spongy bone. Everything here. Okay, okay. These are the spongy bones. Okay, and covering with compact bone. Okay, so there's the reason if a person have calcium deficiency, calcium carbonate or calcium phosphate or vitamin D3 deficiency, their compact bone become very weak. So this compact bone become very weak. So there's the reason whenever they fell down, whenever they have injury or trauma, their bones will break easily. They can caught with fracture very easily. Okay, so you have to remember these things. So irregular bone have red bone marrow within the spongy bone. You have to remember that irregular bone, mostly irregular and flat bones, will made red bone marrow. Okay, you have to remember this. The joint surface mostly in flat bones, short bones, irregular bones. They have red bone marrow. In the red bone marrow, what will happen? The red cells, the blood cells will produce erythropoiesis will occur. Erythropoiesis will occur means formation of blood will occur, will seen, okay, in the bone marrow, red bone marrow mostly. Okay. Next, we will talk about the joint surfaces of bone are covered with articular cartilage. So you can see here, this is the bone. Okay, this is the bone. This is the bone, and this is the bone is covered with another bone. Assume that you have the another bone here. Okay, okay. Actually, this is the pelvic bone. Okay, the this is the ball socket joint. Okay, actually, this is the femur bone, femoral bone. Here again, femur bone. Okay, so if you want to attach this bone, you need movement easily. So there's the region the nature provide you the articular cartilage. Here you have the cartilage means soft bone which will provide friction, easy friction, movement, no rigidity, okay, which provides smooth surface. Covering the rest of the bone is periosteum, and the bone is covering with the layer called periosteum. You have to remember that every bone have covering, okay, each covering that is known as periosteum. Periosteum, a fibrous connective tissue membrane, whole collagen fibers merged with those of the tendons and ligaments that are attached to the bone. The periosteum anchors these structures and contains both the blood vessels that enter the bone itself and osteoblasts that will become active if the bone is damaged. So why periosteum is because everything which will have the bone attached to that, the it will attach to periosteum. Okay, like tendons, ligaments we will talk about later, okay, and blood vessels, everything will attach to the bone, enter to the bone with the help of periosteum. So that's the reason covering is putted for the help of the bone. Okay, so this is all about classification of bones. In the classification of the bones we have long bone, short bone, flat bone, irregular bones. In long bones, in the children's, the red bone marrow is there and it will produce the blood, but later on the children become the adult, it will stop working and the red bone marrow will convert into the yellow bone marrow. We have to remember this. Second thing, that so where the blood is produced in the adult, so the answer is it is produced in the short bones, flat bones, irregular bones. Okay, you can see that this area will produce blood cells. Okay, another thing you have to remember that the bone marrow produce blood cells. Okay, and it is present in the flat bones, irregular bones, short bones. Okay, in the spongy bone it have covering called compact bone, which is hard tissue. Spongy bone is very soft tissue compared to the compact bone tissue. Okay, and bone have the covering called periosteum. So these are the things you have to remember completely. Okay, now we will talk about embryonic growth of bone, how the bone develop. Okay, since the after before birth to after birth, then after, how it will become a longer adult bone and healthy bone. Okay, you need to study this to understood. Okay, let's talk about and we will conclude today's topic here. Okay, during embryonic development means in the uterus when zygote present, okay, the skeleton is first made up of cartilage and fibrous connective tissue. The first step is, this is the first step. Thus, directly the bone is not made. It is made up of cartilage and fibrous connective tissue, which are gradually replaced by the bone. How it is converted? It is converted to the bone. Bone matrix. Bone matrix is produced by cells called osteoblast. So bone matrix, I told in the early lecture that however we build the building with the help of the iron rods. Okay, this is the iron rods. So in that we pour the cement. So this is called the bones. The in the bone, this is called matrix. So in that area, you are depositing calcium. Whatever calcium you are eating, it is deposited in that area. Okay, you have to remember that. Osteoblast means growing cells, producing cells. Osteo means bone, blast means growing, means bone growing cells. Okay, in the embryonic means in the uterus. Skeleton osteoblasts differentiate from the fibroblasts that are present. The production of the bone matrix called ossification begins in center of ossification in each bone. So the process of producing or development of bone is called ossification. The ossification will occurs in the middle of the bone. Here we have the first in the child before birth, the bones like that. This is only cartilage. In that area, the spongy bones, okay, are there, and the cartilage. Most of the bone is made up of cartilage. Okay, then afterwards the ossification starts, and gradually the cartilage which converted into the bone, mostly from compact bone, and secondary ossification occurs here. Then the bone is growing. Okay, here you can see that the whole diaphysis is converted into the bone, and this area is made up, we have cartilage. Then you can see here, this is the young adult bone which is completed its ossification. Okay, this is the matrix. You can see that this is the bone, osteoblast which produce bone, chondrocyte producing cartilage. Okay, you can see that the cranial and facial bones are made up of fibrous connective tissue. Okay, so these are the other details. The first thing you have to remember that ossification which occurs in the middle of the bone, this is very important. And here they give the details that osteoblast, osteoclast means, you have to remember that. Okay, let's talk about everything why you can understood very easily. The cranial and facial bones. Cranial bones means here the skull. The skull bones are called cranial bones. Facial bones in facial bones. Okay, they are made up of fibrous connective tissue. Before birth or after birth means 1 to 2 years age, they are made up of fibrous connective tissue. Okay. After in the third month, what will happen in third month? In the third month of fetal development in the uterus, fibroblast become more specialized and differentiate into osteoblasts. So fibroblasts converted into osteoblasts. They produce bone, bone cells, okay, which produce bone matrix from each center of ossification, bone growth, radiate outwards. Calcium salts are deposited in the collagen of the model of the bone. So afterwards, the osteoblasts produce bone matrix. Then, however, the baby will get the nutritions. Okay, the matrix will filled with the calcium. Okay, so you have to remember that from each center of ossification will develop. After ossification means development of the bone occurs. Okay, this process is not complete at birth. A baby has area of fibrous connective tissue remaining between the bones of the skull. This is called fontanelles. So basically, the we told that we have to carefully see the neck area because it is not completely developed. Why? This this bone is made up of completely with bone matrix, but this area is not completely made up of bone. These have cartilages. So when the child grows, gradually this area will connected like this. That's this. Okay. So we have to remember that that is called fontanelles, which permit compressing of the baby's head during birth without breaking the still thin, thin cranial bones. Because when the natural birth occur, the skull needs to compress. So that's the reason nature kept that bone very flexible, that in the process of the birth the damage doesn't occur. Okay. A baby's skull is quite fragile and must be protected for trauma. So carefully you have to protect the head of the baby till 2 years. So till 2 years, no trauma, no head injury. Then then the skull will attach completely. Okay, and it will protect the baby. The rest of the embryonic cell is made up of cartilage, and ossification begins in the third month of the gestation. The long bones. Osteoblasts produce bone matrix in the center of the diaphysis of the long bones and in the center of short, flat, and irregular bones. Bone matrix gradually replace the original cartilage. So what will happen? That every bone, it may be long bone, it may be short bone, it may be flat bone, it have diaphysis, epiphysis. Okay, in the diaphysis the ossification occurs, mean bone growth occurs. Okay, first of all it is in the cartilage, then afterwards gradually after the birth the cartilage will convert into the compact bone, then compact bone into the hard bone tissue, spongy bone, then compact bone, then adult bone. Okay, here the complete diagram is given, you can refer here. Okay, the long bones also develop center of ossification, the epiphysis. At birth ossification is not yet completed and continued through childhood. In long bones grows an epiphyseal disc at the junction of the diaphysis with each epiphysis. An epiphyseal disc is still cartilage, and the bone grows in the length as more cartilage produced by the epiphysis side. So whatever I told here, it is in written form. Okay. On the diaphysis side, osteoblasts produce the matrix to replace the cartilage. Diaphysis side, the osteoblasts replace the cartilage. Okay, between 16 to 25 years. So it means that your bone develops till at the age of 26 years. You have the chance, you can grow your height. Okay, so this is called closure of the epiphyseal disc. After 25 years the epiphyseal disc is completely closed, no bone growth occurs, no extra amount of matrices will added, only osteoclasts are there, which can replace the or which can uh, replace and uh, remove the damaged area and replace the matrices. Okay, also in bones are specialized cells called osteoclast. Clast means destroying cells. Whenever your bone injury occurs or any calcium uh, bone that is not working very well, okay, the osteoclast will eat that, dissolve that, reabsorb that. So these process called resorption. Resorption. Osteoclasts are very active in embryonic long bones and then reabsorb bone matrix in center of the diaphysis to form the marrow canal. So okay, so all in the osteoclasts are very active in embryonic long bones. Okay, so they reabsorb the bone matrix. You know that bone matrix. Okay, the center of the diaphysis to form the marrow canal. So to produce the marrow canal, the marrow canal is not there. Basically, in the children, you have red bone marrow here, and you have to produce a canal here. So basically, the osteoclast will eat all this area, means destroy all this area, and they produce marrow canal. Okay. After blood vessels grow into the bone marrow canals of embryonic long bones and red bone marrow is established. Okay. After birth, the red bone marrow is replaced by yellow bone marrow. Red bone marrow remains the spongy bone of short, flat, and irregular bones for other functions. of osteoclast and osteoblast. So this is the complete process of bone growth, whatever we studied. So basically, in the initial stage, the bones are in cartilage form. The fibrous connective tissue will produce, and later on, the fibrous connective tissue will convert into osteoblast. Osteoblasts produce bone matrices in that area. The calcium will deposit, and the long bones, the diaphysis and the epiphysis ends are a place of ossification. Gradually, the bone will reach into adult age, then ossification stop, and osteoclast or osteoblast are there. Osteoclasts have the function to remove the destroyed area of the bone. So this is the summary of the development of the bone. Okay, so we can conclude here only. Okay, so today we talked about classification of the bones and growth of bone. Okay, tomorrow we'll talk about growth and maintenance and other topics like fracture, how fracture will be recovered, and then we have the skeleton. We will talk about the skeleton, every bone in detail. Okay, so let's meet tomorrow. Okay, thank you, friends.